Stop paying API fees for latency. Build the next-gen, zero-latency agent entirely on your machine. If your project is scaling past the POC phase, you have to confront a brutal truth: reliance on external cloud APIs introduces fundamental architectural bottlenecks that kill performance and scale. We're talking about latency. Not just the round-trip time, but the cumulative jitter from network hops, queuing delays, and API processing overhead. In a cloud-dependent setup, your agent's decision loop is not milliseconds. It's hundreds of milliseconds away from the hardware, making real-time interaction impossible. That latency isn't just annoying, it fundamentally restricts your use cases. Real-time automation, secure edge filtering, high-frequency trading, these require millisecond ownership. And then there are the hidden costs. Every single inference call translates into a transaction fee, and those fees stack up unforgivingly as usage ramps up. You become a tenant paying for compute cycles you don't control. You are beholden to the vendor's pricing model and their operational uptime. The solution? Bringing the compute to the decision-making point. Deploying the entire model stack locally. When you run inference locally, your bottlenecks vanish. The decision loop becomes purely internal: input arrives, model computes, output acts. This shifts the economics entirely. Your cost is upfront hardware investment and electricity, not variable per token usage. And crucially, you gain absolute data sovereignty. No proprietary information ever leaves your physical control. This is the architectural leap from a scalable hobby project to a production-grade, mission-critical system. So, how do you build this local beast? It starts with model selection and optimization. You cannot just throw a full-sized foundation model onto your local machine and expect miracles. We need efficiency. This is where quantization comes in. We're compressing the model weights, moving from FP32 or even BF16 down to efficient INT8. This compression allows you to maintain near-original performance while drastically reducing VRAM and computational load. Think of it as fitting a massive library into a powerful pocket device while keeping the books readable. Next, we optimize the inference engine itself. You need specialized runners like llama.cpp or VLLM. These frameworks are specifically designed to manage the tensor operations on constrained hardware, maximizing throughput. Let's look at the implementation. Here is a conceptual view of how we initialize and load the model weights for local execution. We use gguf format because it bundles the model weights and metadata into a single, highly memory-mapped file structure. This allows the operating system to map the file directly into RAM, enabling near-instantaneous weight access during inference. The inference loop itself must be tightly controlled. You are managing the temperature, top P, and context window here. This is where you maintain the quality control. The generation parameters are your lever between speed and creative coherence. The final advantage is the decision loop speed. Your input goes in, and the output arrives almost instantly, because no network is involved. By mastering quantization and efficient runners, you achieve true ownership, performance, cost control, and data security. If you're ready to move past the cloud dependency treadmill and build agents that operate at millisecond speeds, this is your technical blueprint.